Okay guys, so today we're going to look at, like I said, using matrices to kind of start working into how do computer systems solve systems of equations that are really big. We're going to start small with systems of 2 and 3 equations, okay? So the method that we're going to use is called, does anyone happen to remember? It's with matrices, it's a specific method. Does anyone remember something called Gaussian elimination? No? All right, well, here we go. So we're looking at the process of Gaussian elimination. All right, so with Gaussian elimination, let's start with a system of 2 equations. So let's say that I have the system negative 4x minus y equals negative 16. And let's say that I have 5x plus 2y equals 17. All right, so as I said before, in order to use a computer, you have to be able to store these systems as something a little bit more efficient, which we call a matrix. So you have to take this system of equations and you have to write it as something that we call an augmented matrix. Okay, so the augmented matrix is basically this box-looking thing, okay? And you'll have what we call the coefficients side of the matrix, and you'll have what we call the solutions side of the matrix. The coefficients are in 2 rows based on the x variables and the y variables. So what you would do is each row represents one of the equations. Whoa, I'm not doing a very good job of drawing an E. There we go. So this would be equation 1, and this row is going to end up being equation 2. So for equation 1, what is your coefficient for x? Yep, so you'd put a negative 4 under the row for equation 1 under the x column. What is your coefficient for y? Negative 1. So you're not putting the variables in this, right? You're just putting the numbers. And then what's your solution? Negative 16. Yep, so you have to make sure before you start putting in an augmented form, if it's not already solved, to be in x, y, equals solution form, you need to rearrange it so that it is. So basically you want to put it in the same exact form that you would to do elimination rather than substitution. That's kind of the form that you're trying to get it in. What would my bottom row look like? What numbers would go across?
5 and 17.
Very good. 5 and 2 and then 17. And you do want to put this bar here to represent that here's the break from the coefficients into the solutions. So if I ask you to take a system of equations and write it in augmented matrix form, this thing right here is what I'm looking for. All right? So what we're going to do now is use that matrix and go through a sequence of steps, and it's basically just doing your elimination steps kind of in a slightly different way. To modify those numbers down to something, all right? And I'll show you at the end, I'll kind of discuss why this form is good. All right, so what I'm going to do is start with that matrix. Let's see if I can kind of give myself a break here. I'm going to start with the matrix, which is negative 4, negative 1, negative 16, 5, 2, and 17. All right, here is your goal. Step 1 is always, always, always going to be to try and make this very first number a 1. The only operations that you are allowed to do is you can multiply an entire row by a number, or you can add rows together. You cannot add just a number onto a row. You can add rows together, so I can take all of row 1, I could take this entire row and I could add it onto row 2, right? That's fine. But what I cannot do is just take 5 and add 5 and then try and add 5 to each of the digits. I'd have to add 5 plus 2 plus 17, okay? Is there anyone who has questions about that? All right. To get a 1 in one of your digits, all you have to do is divide by that number on that row. Remember I said you can multiply by something? So would you agree that if I multiply this row by a negative 1/4, that first number will cancel out to a 1? That's the easiest way to force a 1. Okay, now this negative 1/4 does need to multiply into absolutely everything. Just like if you were doing elimination and you were multiplying a number by the whole entire equation, that's basically what we're doing here. Okay, so this particular matrix is going to turn into, if I multiply that negative 1/4 in, the very first number is now going to be that 1 that I wanted it to be. Okay? The rest of the numbers are going to change too. So negative 1 times negative 1/4 is positive 1/4. Negative 16 times negative 1/4 is 4. And did I mess with the bottom at all? No, I didn't do anything to that bottom row yet. All right, so again, your very first step with this is always going to be to take that very first top left number and force it into a 1, and your way to do that is always going to be to multiply by the reciprocal of that number. That will always cancel it down to 1. And you do that to the whole row. Yes, Ben?
So you said that you could add the second row into the first row?
And in this particular case, if you added that second row, it would give you a 1. But is that always going to happen? Whereas if I multiply by the reciprocal, will that always give me a 1? Yeah, so you're right. In this case, you could have added that second row, and it would have worked, but I'm kind of showing you the way that will always work. Because had that bottom row had, let's say that 5 weren't a 5, where am I? Let's say that this were a 6, would adding it up help us? No. So we have to kind of, what?
When you add them, you just take the number below it and then
add it on.
above it.
Yep, that's what you would do. All right, and we're actually going to kind of see how that works on the next step. Your next step is, now that we have a 1 in that top column, I would want to force every single number below it to be a 0. Sorry. Yep, I'll get it. I know. Oh, it looks like I lost it completely. Nope, there it is. Okay. Okay, so like I said, once I have the 1 in that first spot, I want to force everything below that 1 to be a 0. So the only number I have below it is this 5, right? I need to force that 5 to be a 0. Here's the tricky part. So listen to these steps carefully. If you want a 0, the only row you should ever change is that row that you're trying to force, right? So I'm going to change that first row. Now, notice that I will have this 1 always above it. What would I be able to add to negative 5 to force it to be 0? A negative 5, right? Can I, if this is a 1, what can I multiply this row by to get negative 5? Negative 5. So what I can do to force this is I can take the opposite of the number I'm trying to eliminate. So I want to take negative 5. That's the opposite of the number I want to eliminate. and I can multiply it by that row that has the 1. So if I multiply this by row 1, and that's my notation for it, is just to put an R for row, and then 1 to say the first row of the matrix. And then I can add it to the row that I'm on. Watch what that does on the very first element. So this is the operation you are doing. You're not actually changing row 1, you're just using that mid operation. So if I take the first element in row 1 and I multiply it by -5, what do I get? And then I add it here will become, and that's what we want, right? Now I have to go through and do that same operation on the rest of the row as well. So I would have to take -5 times 1/4. That's what the element in this column is, right? For row 1. So I'd take -5 times 1/4, which would be -5/4, and then I'd have to add onto it the 2. Does anyone not see where I'm going with this? So let me actually start writing this out and you can see what I'm talking about. All right, so I'm not changing row 1. I've already said that, right? That is not the row that I am focused on right now. I'm using row 1, but I am not changing row 1. All right, I've already talked you through. Does anyone have any questions why this element is now a 0? All right, guys, does anyone have any confusion about where I got the 0? Just to talk through it one more time. I'm doing this operation using the first row, so I take, where am I? I take row 1, which is 1, times -5, which is -5, and then add it to row 2, which is -5, or which is going to become 0. Okay, watch this operation again. So I'm going to take -5 times what's in my row 1, right? That's going to give me -5/4, and to that I'm going to add 2. So some of you guys might need to do, write that off to the side to kind of see what's happening. So if you have -5/4 and you're adding 2, what is 2 the same thing as in terms of force? Huh? It's the same as 8 force. So this is going to add up to be 3 force. And that's what should go right here. Okay, we have to do the same thing for the very last entry as well. So you would take -5 times what's in my row 1 for the third column. So -5 times 4 is -20, plus 17 for adding the row 2 part. That's a -3. Okay, I want you guys to take a second to look at that and let me know if you have any questions. That's kind of the confusing step. Okay, so I forgot to record that last little bit, so if anybody's watching that, sorry you didn't get to see how I got to this matrix. But we're at the point where we're trying to change that 1/4 to a 0. I want you guys to take a second and see if you can figure out how to do that, what the operation is. All right, so as I was walking around, I saw a lot of us were getting the correct setup and then just kind of trying to figure out how to carry through with it. So the setup on this would be you want to eliminate 1/4, which means you should get a -1/4 at some point on that. Oops, sorry. Which means you should get a -1/4 to add on to that, right? To do that, though, I have to multiply it by the row that has the 1 beneath it, and that's row 2. And then once I do that, I can add it on to row 1. Okay, so let's go through the sequence of steps on this. I'm going to come on up here for it. All right. So for this matrix, if you look at the first column, when you do this set of steps on the first column, you're taking -1/4 times whatever's in row 2 in that column, right? So 0 times -1/4 stays 0, and then when you add it to the 1, you keep your 1, which is really important. That number should never change. once you've got it. All right. For row 2, this is where we're going to pick up our 0. So if you do negative 1/4 times what's in row 2, you get negative 1/4. Plus 1/4 is how you get, they cancel out and you get your 0. Okay? Then on this row you have negative 1/4 times what's in this row. So you get negative 1, or positive 1, I'm sorry. Negative 4 times negative 1/4 is a positive 1. And then you add that, which is 5. Now we didn't change our bottom row, so that's 0, 1, negative 4 still. Okay, now why was I trying to, I now am in the form where I've got zeros down the diagonal, I'm sorry, 1s down the diagonal, zeros everywhere else. Why was that important to me? Take this out of the matrix form and put it back into, so kind of like do this step up here backwards. So take what's in the matrix and put it back into an equation form. What do you get? Off of this first row, what equation do you get from that? You get 1x, 0y's, so you get x equals 5. On this column, you have 0 x's, 1y equals negative 4. So you have effectively solved for x and y that way. Any questions on that? On why that works? So that is your sequence of steps, always. You're trying to get 1s down the diagonals, 0s everywhere else. You should always start on your leftmost column and get your 1 in that column, 0s in that column. Once you're done with that, then move on to column 2. Get your 1 in that column, 0s everywhere else. Okay? I'm going to give you guys your homework. We're going to work on the 2x2s in your homework for a few minutes, see if you can kind of get going on them, make sure you're on the right track, and then I'm going to interrupt you and come back and do 3x3s after that. Okay? Okay, guys, so we've got a system of 3 equations, 3 variables this time. Your process is basically identical. You just have a few more steps to go through. So for this process, still put your system of equations in augmented matrix form. So let's do that first. So you're going to go across each row, remember, represents an equation. You want your x, y, and z coefficients, and then a bar, and then your solution. So my first equation is going to be represented by negative 6, negative, right? Negative 3, 2, and then I'm going to draw my bar for my solution, 1. Yes?
Why is that 2? Not just used to be 1.
Oh, it's, yes, I'm sorry, I can't, this is so small up here. Yeah, no, you're right. This should be a z, so that's a 1 for the coefficient. Very good. Good catch, thank you. And then the solution is 1. What? Okay, so the x is negative 5. The y on the second equation is 5. You have no z's, so you put 0, and then negative 30. On the last equation, your coefficients are 1, negative 6, negative 5, and 21. Okay, I'm going to zip through this, so just try and follow. What am I changing first? Which number? The negative 6, and I want to change it to?
1.
By multiplying the row?
By 6.
By what?
By dividing by 6. Negative 6.
Or multiplying by negative 1/6. Yeah. All right. Remember that the only row that should change is the row that you have written something next to that you're trying to change. So it's pretty easy on these ones, actually. This row is going to change to 1. That's what I wanted. Negative 3 divided by negative 6 is positive 1/2. 1 is going to be negative 1/6. And then I've got another negative 1/6. I'm going to kind of try and make my matrix a little bit bigger. Okay. And then I just fill in the rest of the rows. What is my next goal to change? Right. I'm going to start working down the column. Now, the nice thing is that you can, once you have a leading 1, you can actually change both of these to a 0 all in the same step to the next matrix. That's fine. Zeros you can do kind of all at once in a column. So for this second column, I'm going to multiply. What am I going to do? What's my operation? 5. Okay. What am I going to do for my last row? What's that operation going to be? Right. Negative 1 times R1 plus R what? R3 because you're on R3. Very good. So follow with me really quickly. I'm going to probably go through this faster than what you guys are comfortable with, but hopefully enough to the point where you can keep up. So I'm going to do all of my second row first. So my operation is going to be to think about multiplying all of the row 1 by 5 and then adding it to the row 2 below. So if I do that for the first element, 1 times 5 is 5, plus row 2, negative 5, that's my 0, right? Now am I changing row 1 at all? So I can just copy my row 1 in down here. I don't want that to change. I just talked through why this is a 0. Now let's go through the rest. So again, I'm multiplying my row 1s, all of my row 1s by 5, and then adding it. So if I multiply this by 5, I get 5 halves plus 5. And you guys might want to do some just kind of like quick notes on the side. So if I'm doing 5 halves plus 5, that's 5 halves plus 10 halves to get a common denominator, which will be, what? 15 over 2. Very good. So it will help you just to kind of make those quick jots on the side. For negative 1, 6, I have actually, I'm going to have the same exact thing for the negative 1, 6, but I'm adding 0, and then I'm adding negative 30, so that's what I'll have to watch. Negative 1, 6 times 5 is going to give me negative 5, 6. Now in the one case, I'm just adding 0, right? So this is going to become negative 5, 6 without any extra work. Whoa. On my last column, though, I need to add or subtract 30 for that, for the second one, right? But how many 6 is 30? Yes. So that's negative 185, 6. So I have to kind of squeeze this in. Sorry. If you guys can't read that very well. All right. For the third column, I am multiplying by negative 1. So basically all you're doing for the third column is changing the sign on all of your row 1s and then adding it to your row 3. So change the sign here as a negative 1 plus 1. That's what gives us our 0. Okay? Change the sign on the 1/2. That's negative 1/2 minus 6. So that's something you might jot off to the side. Right? If you do negative 1/2 minus 6, what is 6 in terms of halves? So that's negative 13 halves. Very good. And then you get, change your sign on this is a positive 1, 6, and you're adding it to negative 5. So positive 1, 6 plus 5. What is 5 in terms of 6? Good. So that's 31, 6. This is a prime example of where your fractions look ugly, but you just got to hack through it. Watch your signs. That's kind of the key. For the last one, we're going to get a negative 1/6 again, and then, or a positive 1/6 again, and then we're adding that this time to 21. So 21 times 6 is, what? 46?
26.
26. So then that's going to be 127 sixths, right?
Wait, aren't you subtracting when you do negative 125, 6?
I don't think I am subtracting because that's a positive 21, right? So I have changed the sign as positive 1/6 and then add it to this number. Last time I subtracted because it was a negative 30. Or did I subtract it? Yes. Did I? I don't see it. I did. Yeah, that was this stuff.
Negative 5, I think we added.
Which one? This one? I don't see where I'm at. Oh, on this one? Yes. You're right. So on this guy, I should have done, not that, you're saying I should have done minus. So then that would be negative 29 on that. Good catch, thank you. Okay. All right. So I can erase all my scratch work since I am done with it. Okay. Now I've got one whole column done, right? So now I am ready to move on to the second column. What number do I want to change in the second column first? Nope. Always change the diagonal number first to a 1, and then work on the zeros. So how am I going to change that to a 1? I'm sorry, what? 2 over 15. Multiply by the reciprocal. Okay, so if I make that change in my new matrix, I'm going to get... My first and my last row are not changing at all, so I'm just going to copy those guys down. Okay, my second column I'm going through and multiplying by 2/15. The 0 won't change. That middle number is going to change to a 1. What do I have there? I can't tell. 5, 6? Negative 5, 6. So I'm going to try and think about what that's going to be canceled out as I go. So this 5 is going to cancel with the 15 to leave 3 on the bottom, right? And then the 2 and the 6 are going to cancel to leave 3 on the bottom. Do you guys see that? So the top, both the 2 and the 5 got knocked out. So I have a negative, and then I had 2 3s left on the bottom, which multiply to, so that's a negative 1/9. Okay, again, I'm going to think about here what can cancel. Does 185 divide evenly by 15? I feel like it doesn't. Oh, you're right, you're right. I was thinking 195. So, but they both divide by 5, right? So if you divide them by 5, what do you get? So 37 on top. Okay, and we're going to keep a negative, so that's going to be negative 37 on top. On the bottom, when you divided by 5, you had 3 remaining here, and I also divided the 2 by 6 to leave a 3 here, right? So you still have 9ths, is that correct? And then we're just copying in row 1 again. Oops, that should be a 6. And then 127 over 6. All right, now again, you guys, I'm probably going to get cut off here, but I hope you're seeing them. I'm giving you enough that you should be able to now finish your homework. I'm going to keep on going so that you guys can see this last thing. So now we're changing both of these to zeros. Again, you can do that in one step. So this equation is going to be negative 1/2 times row 2, since that's where my leading 1 is, plus row 1. Please don't pack up yet. This row is going to be 13/2 times row 2 plus row 3. Are there any questions on where I got that? Okay, so I'm just going to get through as much as I can before the bell rings. And then your homework is going to be due on Monday. All right, so for this guy, I'm not changing row 2, so I'll copy that in just a second. What I'm doing is taking negative 1/2 times everything that's in row 2 and adding it to row 1. So this is going to stay because no matter what I multiply by 0, stays 0 plus 1. Here when I multiply by negative 1/2, I get negative 1/2, add it, that's how we're getting our 0. And now here's where I have to go through the work. So negative 1/2 times negative 1/9 is positive 1/18. And then you're subtracting 1/6, which in terms of 18ths is 3/18. So you have 1/18 minus 3/18, which is negative 2/18, which is negative 1/9.
Would it be negative 2/18 or would it be...
Maybe, I'm doing this really fast. Let's hear. So let's go through that one time.
Never mind. I was wrong.
Okay, I'm going to keep on going then. All right, so this is going to become positive 37/18 minus another 3/18. So positive 37 minus 3 is 34/18. Both of those divide by 9 to 17/9. I can copy row 2 down. I think I'm about to get cut off. Do we all get the point? This is going to be a 0, this is going to be a 0, right? And then I'm going to go through the work to figure out between these two numbers and these two numbers, where did I get here? On the last column, you're going to force your 1 and then more zeros. All right? Thanks, guys.